Okay, again, we're on page 15, and we're going to do some more practice on solving by factors. That was the notes that we took together yesterday. You had some practice for homework last night. So we're going to continue to look at solving by factoring today. What's the first thing I always want to look for when I'm factoring? Look for a GCF. And then if I'm going to solve by factoring, right before I look for a GCF, what do I need to make sure of? This was new for yesterday. And actually, if I flip back to my notes, we had a couple of problems. Yeah, I need everything on the same side set equal to 0. So once everything is on the same side set equal to 0, so we're good on number 1. We're going to have some work for a couple of these others, but we're good on number 1. Once everything's on the same side set equal to 0, then I'm going to look for a GCF. Do we have a GCF for number 1? X squared, we sure do. When I factor that out, I'm left with x minus 3. And now I'm going to set each of these factors equal to 0. I can't factor either of these pieces anymore. X squared is just x times x, so I can leave that as x squared. And then x minus 3, I don't have any more powers of x, so we're good there. So I'm going to set x squared equal to 0 and x minus 3 equal to 0 to find my solutions. X minus 3, we're going to move the 3 to the other side, and we would get x equals 3 for a solution. And then how about x squared equals 0? This is kind of a good little preview problem for the next thing that you're going to see. Why would it just equal 0?
Because you're dividing 0 with the x minus 0.
Not quite. Yeah. So the idea is we're looking for something squared that equals 0, which you're right, is going to be 0. So if it was not 0, if I had a different number over here, one way that I could approach this would be to say, hey, let's undo the square. So that would be to take a square root, and we would get 0 here. Now, I do want to point out, we had a problem yesterday where we looked at that fundamental theorem of algebra. What's the degree? How many total zeros should I have? And it didn't seem to line up. Keep in mind, x squared means that this would be quadratic behavior, and this would count as 2 zeros for our polynomial. Okay. But to factor, pull out our GCF, solve each factor, set each factor equal to 0, I should say, and solve for x. And there are our solutions. Let's take a look at number 2. What's going to be my first step over here on number 2? Yeah, I need everything on the same side set equal to 0. So this 2 has got to move. So that gives me x cubed plus 2x squared minus x minus 2. You cannot factor until you have everything on the same side set equal to 0. Okay, 100% of the time for the problems that you see for me, if you start factoring and you don't have everything on the same side, you're not going to find correct solutions. Okay, you need everything on the same side set equal to 0. And now I've got everything on the same side set equal to 0. And I've got 1, 2, 3, 4 terms. How do we approach something that has 4 terms? Grouping, yeah. Group those first 2 terms, group those second 2 terms. And then what do I do with each group? I heard it. Yeah, I'm going to look for a GCF and factor it out. What's the GCF for my first factor? Perfect. What's left over when I pull that out? Very good. And then how about my second group? What's the GCF there? -1. Yeah, since my group starts with a negative, it's a pretty good hint that I'm going to factor out a negative. So that would leave me with x plus 2. Remember, factoring out that negative will change these signs. And then remember, your stuff in parentheses should always be the same. If it's not, go back and double check your work. This should always match this. Since ours does match, that's our new GCF that we pull out. And then left over, I've got x squared minus 1. And now we still have an x squared term here in this second factor. So that should send up some alarm bells that, hey, maybe I'm not done factoring yet. Right here, we have a difference of squares, right? 2 terms, even degree, subtraction. I want to think difference of squares. So what did I square to get the first term? And what did I square to get the second term? Yep. So this second part here, I can continue to factor into x plus 1 times x minus 1. So I know this is a little tiny, but my fully factored form would be x plus 2 times x plus 1 times x minus 1. The factoring portion is done now, so I can find my solution. So I'm going to take each of my factors, set them equal to 0, and solve for x. So we would get x equals -2 as the solution, x equals -1 as the solution, and x equals +1 as the solution. Questions for me so far? Okay. Let's take a look at number 3. Number 3, I've got 4x squared equals 49. What's the first thing I need to do here? Yeah, I've got to move that 49 over, move everything to the same side. And then I think you said difference of squares. Yeah, once everything's moved to the same side, we have a difference of squares here. 2 terms, even degrees, subtraction. I want to try difference of squares with my factoring method. So I need to know, what did I square to get each part? What did I square to get 4x squared? 2x. 2 squared gives me 4, x squared gives me x squared. And then how about the 49? So my factored form here would be 2x plus 7 times 2x minus 7. And now my factoring is done. So I'm going to set each of these equal to 0 and solve for x. So we've got 2x plus 7 equals 0 and 2x minus 7 equals 0. We've got a little more rearranging to do on this one. That's okay. We will get x equals -7 over 2. My last step would be to divide both sides by 2. And then here, oops, forgot the equal 0. There we go. And then we get x equals +7 over 2. I would like you now to try number 5. What's my first step here? We got something to do before I look. Yeah, I gotta move that 16 over, and then I can take out a 16x. So we have x cubed plus 8x squared plus 16x equals 0. And then we have a GCF of x here that we can pull out. So that would leave me with x squared plus 8x plus 16 equals 0. And now I've got 3 terms for the part I need to keep factoring. So if you're an AC method person and you want to use AC method, you can absolutely do that. But this one, we can use that sort of shortened version. So I need factors of 16 that would add to 8. What do I want? 4 and 4. So this would become x plus 4 times x plus 4. And then don't forget the GCF we pulled out at the beginning. And then I'm going to set each of these factors equal to 0. And for the x plus 4s, I'm going to get the same solution out of both of these because it's the same thing. So if you set each of them equal to 0 and give me that -4 twice in your solution list, that's fine. If you just write it once, that's fine too. But remember, if I ask you, and then x equals 0, there's nothing to do there. If I ask you how many real zeros are there, remember we've got 3 of them. Okay, one of them we see twice, but that doesn't change that we've got 3 real zeros there. Questions for me on number 5? Okay, let's take a look at number 7. So again, we're going to start by moving everything to the same side. So I'm going to move this 4x squared over. That would give me x to the 4th minus 4x squared equals 0. And then just like number 5, we've got a GCF that we can take out. What is our GCF here? X squared. That would leave me with x squared minus 4 equals 0. And then what can we do with this guy in here? The difference of squares. What did I square to get the first thing? What did I square to get the second thing? Perfect. So my factored form is x squared times x plus 2 times x minus 2. My solutions then, I could find by setting each factor equal to 0 and solving for x. So we had an x squared equals 0 before. Said we would take a square root on both sides, and we ended up with x equals 0. Here, subtract the 2 to the other side, and we get x equals -2. And then here, add the 2 to both sides, and we get x equals +2. Let's take a look at number 8 together. This sort of kind of looks like a vertex form, doesn't it? A little bit, something in parentheses squared and then a number at the end, okay? We're actually going to revisit problems like this in a couple of days, but for right now, we're going to solve this by factoring. So we talked about being able to take something in vertex form and write it into factored form without having to distribute and go through standard. And the idea was that we treated this like a difference of squares. So I've got 2 terms. The big one's kind of clunky, but I've got 2 terms. This is already written as something squared. I've got subtraction, so I just need to know what did I square to get the last part. So what did I square to get 36? 6. So I could write this as the first thing, 2x plus 3 plus the second thing. And then the first thing again, 2x plus 3 minus the second thing. And then I'm going to clean these factors up a little bit, combine those constant terms in there. So we get 2x plus 9 times 2x minus 3. And then I'm going to set each factor equal to 0 and solve just like we've done for every other problem today. So 2x plus 9 equals 0 and 2x minus 3 equals 0. I want to get x by itself. So I get x to be -9/2. And as long as your fraction's reduced, fractions are perfectly fine answers. You don't need to change these to decimals for me. So -9/2 and 3/2 for my solutions there. Now I would like you to try 9 and 10. You try 9 and 10.
For number 9, our first step is to pull that GCF of 3. Everything's already on the same side, so I don't have to move anything around. I can go straight to pulling out my GCF. And then what I'm left with has a lead coefficient of 2. So I'm going to use the AC method on this one. So I need to take 2 times 14. That gives me 28. And I want factors of 28 that add to 11. That would be 4 times 7. I'm going to replace the 11x with 4x and 7x. So I have 2x squared plus 4x plus 7x plus 14. And now that I've rewritten this in 4 terms, I'm going to use grouping. The GCF for my first group is 2x. That leaves me with x plus 2. For my second group, the GCF would be 7, which leaves me with x plus 2. My stuff in parentheses is the same, so I'm going to pull that out. And then I'm left with 2x plus 7. Now don't forget that 3 that we pulled out at the beginning. And there's my factored form. Now I'm going to set each factor equal to 0, and that's what I've told you all along for the last couple of days, set each factor equal to 0. But what I really mean is set each factor with an x equal to 0. So 3 is a factor of this thing. But if I set 3 equal to 0, is there an x for me to solve for there? No. And is 3 equal to 0? No. So this is kind of garbage. What I really should have been saying is set each factor with x equal to 0. So we want x plus 2 equals 0 and 2x plus 7 equals 0. So we get x equals negative 2. And x equals negative 7 over 2. For number 10, my first step is going to be to move everything to the same side. So this 3x squared needs to go to the other side. And in this case, I have another x squared term already on the left-hand side, so I need to combine those like terms there.
So I would have x cubed plus 2x squared minus 35x equals 0. I've got a GCF of x that I can pull out. That leaves me with x squared plus 2x minus 35. And then I want factors of negative 35. That would add to 2. What do I want? What factors? 7 and 5, and one of them's got to be negative. Make the 5 negative. So my factored form would be x times x plus 7 times x minus 5. So my solutions would be x equals 0, and then that one's already solved for me. And then x plus 7 equals 0. So x equals negative 7. And then x minus 5 equals 0. So x equals 5. Questions for me? Okay, so the factoring parts we've done already. The solving parts were new yesterday. But again, it's really the same thing that we were doing when we were finding those x-intercepts.